Let me tell you a story about a flagpole, a man, and his box. Equivalent figures problems are a pretty common question on the GED. It's basically a ratios question. In your textbook, you find it in the geometry section, but it's just ratios. And of course, anything that's ratios is triangles, and we'll see that in the story. A man and his box are standing in the shadow of a flagpole. If the shadow of the flagpole is 30 feet long, and the man is 6 feet tall and casts a 12-foot shadow, how tall is the flagpole? Now this question seems confusing until you realize that this is just what we call a two-triangle problem. The shadow of the sun casts across the flagpole, the man, and the box will all be at the same angle because the sun is very far away. And so that is all the same. And once we can identify the different triangles, and there they are, now the problem becomes quite simple. I simply have a ratio question. In this case, I have a 6:12 ratio for the man, a 6:12 ratio for the man, and I don't know ratio to 30 for the triangle. And so I can just simply cross multiply divide, or in this case I would actually divide and then cross multiply. 6 divided by 12 is a half. A half times 30 is simply 15. And so I can see that I just have an expansion of the triangle that was created by the man to be as tall as the flagpole. Now an extension of this would be to ask, well, if the box is 2 feet tall, then how long a shadow should it cast? Pause the video, identify your two triangles, create your ratio, and answer your question. In this case, there's a number of ways we could actually solve it. One way would be to compare it to the shadow of the man. He was 6 feet tall, and he cast a 12-foot shadow. Or we could compare it to the new information we got. The 15-foot flagpole with a 30-foot shadow. Now, hopefully you can see, just with your intuition, that a 2-foot box would cast a 4-foot shadow, because a 6-foot man is casting a shadow that's twice as long, and a 15-foot flagpole is casting a shadow that's twice as long. So the box would certainly do the same. But if you didn't see that, you could just use a ratio. And you could think, well, if the man casts a 6-foot, if the 6-foot man casts a 12-foot shadow, then a 2-foot box should cast a uncertain length shadow. And then I can just cross multiply and divide. 2 times 12 divided by 6 would give me a 4, which was the answer we got by intuition. And it wouldn't matter if you did it that way, or if you used the new information you had about the flagpole. In this case, you would get 2 times 30, or 60, divided by 15, which is also a 4. And there you have it, a story of a flagpole, a man, and his box.